Hi guys, welcome to lecture 5. Today we are going to do empirical and molecular formula using what we learned in lecture 4, which was percent composition. So again, more things that we can do with mass and moles. You're going to find that some of this is review and some of it is using old things to do new things, and there's a lot of little steps, but they are all very manageable. So here we go. First, a reminder about the differences between empirical and molecular formula. We learned this back in, I believe it was week 28. Remember that a molecular formula is a formula that shows you the actual number of atoms that are in a molecule of a substance. So it's telling you what is literally actually present in your particular compound. The molecules are particles that are formed from covalent bonding. Remember, covalent bonding is non-metal. So you're going to notice that this is very often done with covalent compounds. That is different than an empirical formula. An empirical formula is the lowest whole number ratio of that real molecular formula. To find the empirical formula, remember that you divide all of the subscripts by the greatest common factor. So you're really just reducing it down to the bare bones to give somebody the ratio of the different types of elements that are present. We've done this before, but we're going to do it one more time here just to be sure that we're all on the same page. So if we're going to practice here, we're going to take these and find their empirical formulas. So you look at your two subscripts and you decide what is the greatest common factor. So it looks here like I could divide these both by 2. So this will turn into, if I divide 2 by 2, I get 1, and if I divide 4 by 2, I get 2. So this turns into NO2. So this one is my molecular formula. This is my reduced empirical formula. Now here I've got NH3. Now N has got like an invisible 1 there, right? I can't divide the number 1 by anything other than 1. So it looks like this one, my empirical and molecular formulas must be the same, and that's okay. That happens sometimes. All right, let's come up to this C4H10. So in C4H10, they're both even numbers, so I think I can divide them both by 2. So that's going to give me C2H5. Now these are also all even down here, right? And I could divide them all by 2, but if I did that, I wouldn't get the lowest ratio, and I need the lowest ratio. And so I did notice that I've got 6 and 12, and I know that 6 will fit into 12, so I'm going to divide everybody by 6. Right? So this becomes CH2O. So we've done this before. We're not going to do a lot of this. This is just a quick refresher of what we already know how to do. So now let's look at how we use this kind of skill that we learned before. Okay, don't panic. I know there's a lot on this screen, but this is the data table that is in, excuse me, that is in your note packet. It's just put together a little bit differently so it would work on the slide for me so I could write on it for you. Okay, so we're going to do the first row on your packet, and that's going to be this column, right? It's not in the same order, and I'm sorry, but this just worked better. So in order to determine the actual molecular formula of a compound, we can use its formula mass, right, its molar mass, and its lowest ratio, empirical formula, to get the new formula, the big molecular formula. Sometimes we call the molecular formula, we think of it like the fluffy version. So you need a couple of pieces of information. You need the empirical formula, which you have on your paper, and then you need to know how much this lowest ratio weighs. So to find that, right, you're just going to look up each one of these and add them up. So 12.01 times 3, 1.01 times 4, 16 times 3. We add them all up. So when we add them all up, I got 8806. Okay, so we have to do this step usually. We also need to know the molar mass, that's what my big MM stands for, of the molecular formula. Right? You have to be given this because how would you know? You don't know the molecular formula. There's no way you could actually get this number. So this number is given to you. Okay? So what you do is you divide these two numbers. You're always going to put the bigger one on top, so 176, and you're going to always divide it by the smaller one. And when you do this, you should get a whole number. Now, if you get a fraction, right, you are a decimal that's not incredibly close to a whole number, you've just done it upside down. Just flip it over. So I've got 176 divided by 88. Well, this gives me 2, or like 1.99999. So it gives me the number 2. It has to be a whole number. This number 2 is my multiplier. It is like the fluff up factor. So that means that the empirical formula up here is one thing, but the molecular formula is twice as big. So I'm going to take each one of these subscripts and I'm going to multiply them by 2 to make it twice as big. So this becomes C6H8, and then 3 times 2 again, O6. Okay. So this is our multiplier. That's the connection between the empirical formula and the molecular formula. Now, you have all of these on your paper. I have already looked up these masses. So if you want to try these on your own, if you're at home, I would suggest that you maybe hit pause and then try them and then come back to them, because we're going to be doing them together in class. But since this is a recording, it's a little faster usually than what happens in class live. So I add up the CH3 and I get 15. They've told me that the molecular formula weighs 45. So again, I put the big one on top so that I get a whole number. And this turns out to be 3. So that is my multiplier. I need to make this empirical formula 3 times bigger. So this becomes C3 and then H9. Okay. Same thing here. Add all of these guys up. I got 7307. They've given me the 146, so I put the heavy 146 on top of the not so heavy 73. Okay, this gave me a multiplier of 2. So every single one of these subscripts, including the invisible one on the oxygen, has to be multiplied by the number 2. So this becomes C4 H10 N4 O2. And then the last one here, my C5H9. So again, I look up how much C5H9 weighs. I add them all up. I got 6914. The molecular mass of the molecular formula is really big, 345. So 345 divided by 69 gave me a multiplier of 5. So I have to make this formula 5 times as big. So 5 times 5 for my carbon gives me C25, and 5 times 9, wow, that gives me 45. So that's really big, but that's okay. This is just how it works, okay? So all of these show you how you can take the empirical formula that we know and we can turn that into a molecular formula simply by finding the multiplying factor. Okay. So now let's let you guys try one. Again, I would hit pause if you're at home and maybe give it a shot yourself. I'm going to walk through it here kind of in real time, but it's always good to practice first because, you know, in class I give a pause while everybody does it. So I'm going to pull the information that I need out of this problem so I'm not having to read this over and over again. I think that makes it a little bit easier for most people. So here we go. Let's see, I've got CH is my empirical formula. They tell me that it's got 78 is the molar mass, and they want me to find the fluffy molecular formula. So I'm going to look up CH on the periodic table. It's like 12 plus 1, so it's like 13. So this then becomes 78 divided by 13, which is 6. So this is C6H6. Okay. Again, if you don't get a whole number, a couple of things you can try. Definitely double check your molar mass that you looked up yourself and just make sure that you've got the heavier one on top. Those are the 2 places where mistakes tend to happen. So now that we know how to take an empirical formula and turn it into a molecular formula, the next thing is There we go. Using those percent compositions that we learned earlier in the week to figure out the empirical formula, right? So this time we're not giving you the empirical formula, you're going to find the empirical formula. Now, in your note packet, you have this information on the little blue tag kind of off to the side in a bubble for you, but I've given you a lot of room on your paper to see each step. I don't have that much room on the slides, but I'm going to try to match them up for you so you can tell what's going on. So these over here on the little blue, like it's not really a post-it note, but over here, these little blue things, these are the steps for solving a problem to find the empirical formula. So it's percent to mass, mass to moles, divide by small, multiply until whole. Sometimes you have to do all 4 of these steps. Sometimes you only have to do like 3 of these steps or even 2 of these steps. But the important thing is that you always start at the top with percent to mass and work your way down. Okay? You have to do them in the right order or it will not work. So first step is to change the percentages that you're given, which is 50% sulfur and 50% oxygen, is to change those numbers to mass. Okay, so guys, don't make this harder than it is. Assume always, because all of these things add up to 100%, assume that it's a 100-gram sample. So if I have 50% of 100, I have 50, right? If I have 29% of 100, I have 29. So really all you're doing is changing this percent sign into the word grams. It's the easiest step in the world. So for step 1, I'm just going to change the percent sign into a gram sign. Now notice how I am setting this up. You want to put these on top of each other, give yourself a little bit of room in between them because keeping your work organized is going to be key here. Okay, so that was step 1. We just changed percent to mass. Now step 2 says change the mass to moles. So that's the conversions that we talked about last period. Remember we reviewed that? So I need to change each one of these masses into moles. So I'm going to do my little one-step conversion. I'm going to bring down the grams and I'm going to change it to moles. Now, I like to set mine up and then go back and put the numbers in. You can do it however you like. That's just kind of how I like to do it. So I look up oxygen is 16 and sulfur, oh, I didn't give myself very much room, is 3207. So this is step 2. Changing mass to moles. We already know how to do this. Now here, I'm going to write down my numbers. Now notice I'm not even thinking about sig figs right now, and that's because my answer is going to actually be a formula. It's not going to be numbers like this at all. So this is really important over here. Don't round off things until the end. I like to keep at least 3 decimal places in this step for this type of problem. Okay. So that was step 2. Mass to moles. Now, step 3 is also very easy. Divide by the smallest number that you get. So you take these 2 numbers that you just wrote down, and whichever one is smaller, you divide them both by that number. Now, the reason we're doing that is we're trying to get a ratio, right? Lowest ratio of the atoms. And so one of them should always be 1 because you're dividing by itself. So I'm going to divide, and this one comes out to 2, all right? So what I'm looking at here, I divided by small, is I'm looking at a ratio of 1 sulfur for every 2 oxygens. Now on my calculator, these came out incredibly close to whole numbers, so I don't need to do the last step. I already have whole numbers, so I'm good just the way I am. So the question was, what is the empirical formula? Well, the empirical formula is the lowest ratio, and my ratio was 1 sulfur for every 2 oxygens. So a compound that is 50% sulfur and 50% oxygen by mass has a formula of SO2. That's how you do it. So again, takes up a good bit of space, has these steps, but they're super easy. Now I am going to put a little, I didn't give myself a lot of room here, but I'm going to add it down here to the bottom because it's in your notes, which is what happens if you don't get whole numbers when you do this dividing everybody by the small. That's okay. If you get like a 0.5, right? Maybe you got like 1 and 2.5. That's okay. You multiply everybody by a multiple just to get it to be a whole number. So You know, how many halves does it take to make a whole? It takes 2. So you'd multiply everybody by 2. If you got a quarter in one of your answers, you'd multiply everybody by 4. And of course, if you got a third, you'd multiply everybody by 3. Usually 2, 3, or 4 is all you have to deal with. A lot of times like this one, you don't even have to do that, right? It automatically comes out to whole numbers. So let's do another one so we can make sure we know what we're doing before you are cut loose to do them on your own. Okay, get back my chalk colored pen. There we go. All right, so look at this one. This one's got 3 elements in it, but notice the steps over here on my little blue tag, they haven't changed at all. I've kept them the same. That's because it doesn't matter how many elements I'm dealing with. I still go through these steps. Start at the top, work my way down. So percent to mass just means turn it into grams. Notice I'm keeping everything labeled so I don't get confused. And I'm giving myself plenty of room. Now I know these are going to be hard to do on Google Docs. So this is probably one of those things you're going to want to do on paper and take a picture, and that is 100% okay. So that was step 1. Step 2, change the mass to moles. So every one of these, I'm bringing down the grams, changing it to moles. Okay. Like I said, I like to fill mine out first and then go back and put the numbers in. Okay, like that. I know carbon is 12. I have to look up lithium, so let's see. 6.94. All right, so now I can calculate. So 18.7 divided by 6.94. Remember, don't round off too much. Keep at least 3 decimals. So let's say 0.710. 16 divided by 12. 1.358. And 65 divided by 16 looks like 4.065. Okay, so mass to moles, done. These don't look like whole number ratios. That's because I still have to divide to get the whole number ratio. So I look at these 3 numbers. It looks like the 1.35 is the smallest one. So everybody gets divided by 1.35. So I'm simplifying it here basically. So this gave me a 2. One of them is always a 1. And this one gave me 3. So here's my ratio. 2 lithiums, 1 carbon, and 3 oxygens. This is my answer. So before I set you loose to work on your own practice problems and worksheets that are in Google Classroom, please, please, please understand you have to show your work for these. So if on paper is the way to go for you, that is fine, but I have to see your work. When we have problems that require lots of steps like this, every step along the way is getting you points, right? I can't just take this answer at the end and be sure that you know what's going on. So you're getting points for changing grams to moles. You're getting points for dividing by the smallest number. You're getting points for getting the right answer here and knowing whether or not you need to multiply to get a whole number or not. So there's a lot of things that go into getting this answer. So if you want all the points for all this back work, you have to share that back work with me, okay? So this is the second big thing for this week. Now we're going to practice, and remember that if you have any questions, you can always reach out for help.